Hey everyone and welcome back to the channel. In our last video, you built your first serverless API with API Gateway and Lambda. You had a public link that actually ran your code, which was awesome. But what if you wanted to build something a bit more useful than a simple hello world? What if you wanted to build an API that could actually save and retrieve information? Well, that's exactly what we are going to do today. We are going to add a database to our stack using a service called Amazon DynamoDB. That is to make our API truly functional. Let's get right into it. Just to quickly recap our journey, we have now this amazing architecture. We have a public facing API that receives web requests, which then triggers our serverless code in Lambda. But as you can see, there's something missing. Our goal today is to give that code a place to save data. We are going to take our simple hello world function, connect to a DynamoDB database, and turn it into a data-driven API that can power a real-world application. So what exactly is DynamoDB? At its core, it's a fully managed serverless NoSQL database. Now you might be thinking, what's the difference between this and the traditional database? Well, unlike the relational databases we have worked with before, like MySQL, which are very structured, DynamoDB is a lot more flexible. The best way to think about it as a super fast, infinitely scalable digital filing cabinet. You can store all kinds of different files, like a document, an image, or a user profile, and it can instantly find anything you are looking for, no matter how much data you have thrown in it. This flexibility is what it makes it so powerful for modern development. Okay, to get a handle on DynamoDB, you just need to understand three core concepts. First, you have a table, which is like a big folder that holds all of your data. Inside that table, you have items, which are the individual pieces of data. And finally, this is the most important part, each item has a primary key. This is the unique identifier that DynamoDB uses to find your data instantly and efficiently. So you don't need to define every single column in your database upfront. You just need to tell DynamoDB how to find the item and you are looking for. Alright, with those concepts in mind, let's look at the plan. It's a really simple three-step process. We will first create our database table right in the console. Then we will hop out to Lambda function and update its permission to make sure it's allowed to access our new table. And finally, we will actually write the code to make it all work, showing you how to put and get data from the database. I will walk you through each step, and by the end, you will have a fully functional application. Alright, so now it's time for the live demo. I'm going to walk you through the process of building this entire data-driven API from scratch. First, because we always clean up our resources to save money, I will quickly recreate my hello world lambda function and my gateway endpoint, the API gateway endpoint. Then we can get to the main event, that is the DynamoDB. I will create the table, showing you the most important part, that is defining the primary key. Once that's done, we will edit our lambda function's IAM role to give it necessary permissions, and then we will write a simple Python code to make our API talk to our brand new database. By the end of this demo, you will see the entire stack working together seamlessly. Alright, let's get started with our live demo. We are building a complete serverless API from scratch. So we are starting with a clean slate. This is a great way to see how all the pieces fits together. First, let's create a Lambda function. In the search bar, I will type Lambda and go to the service. On the Lambda dashboard, click the Create Function button. We are going to choose author from scratch and let's give it a name, My Data API function. For the runtime, I will select Python 3.9. Leave all other settings as the default and click Create Function. Let's wait for it to create. But before we write any code in this function, let's create the database that our function will talk to. I will go into the search bar and search for DynamoDB. On the DynamoDB dashboard, click the Create Table button. First, let me delete the existing table that is there. Okay, go to the dashboard and click Create Table. Let's give our table a name. I will call it My Data API table. Now, this is the most important part, that is the primary key. This is how we will uniquely identify each item in our database. I will call my partition key ID, I will call it ID. ID will be the partition key and the type will be the string. This is a very common setup for a simple API. Leave all the other settings as defaults and click Create Table. Our Lambda function needs permission to talk to this new database. It can't do anything by default, which is a great security feature of AWS. Let's go back to our Lambda functions. You can either use this back button of the browser, or you can search for Lambda in the search bar. I will use this back button and go to my data API function. On your functions page, click on the configuration tab. Then click on the permissions in the left menu. You will see an IAM role here. Click on that name and this will take you to the IAM console where we can edit our permissions. Once you are on the IAM role page, click on Add Permissions and then Attach Policies. In the search box, type DynamoDB. And then we will select this Amazon DynamoDB full access policy for this demo to keep it simple. In a real application, you would want to use a more specific policy. That is because of the less access. So just make sure and click on Add Permission. Perfect. The policy was successfully attached to the rule. Now our function can read and write to the database. Let's head back to the Lambda function. Go back to the code editor. I will scroll down. Ignore this thing. Perfect. This is the sample. This is the default code. I will replace this default code with a simple function that can handle both a post request, that is to save data, and get request, that is to retrieve data. I have this code ready and I will just copy and paste it here. Let me quickly explain what is there in this code. We are importing the Boto3 library to talk to the AWS services. We are creating a DynamoDB resource and pointing it to a table name. We are checking the HTTP method from the incoming request. And if it's a post, we will try to get the data from the body and put it in our table with a unique ID. If it's a get, we will scan the entire table and return all the items. This is a great simple example of how to make your API dynamic. Perfect. After the pasting this code, click the deploy button. This saves your changes and makes the code active. Okay, successfully updated the function. Now let's create the front door. In the search bar, I will type API gateway. I will click on the service. Once the API gateway dashboard opens, click on create an API. And click on the build button for HTTP API. First, let's give our API a name. I will call it my data driven API. Click add integration. For the integration type, select Lambda function. And for the Lambda function dropdown, select the Lambda function that we have just created. That is my data API function. Click on next. On the routes page, there is already existing route. We will change the method to post and the resource path to /items. This integration target, we will keep it as my data API function, that is the Lambda function. I will create another route, add another route, and for that I will select the method as get and the resource path as /items. Integration target would be our Lambda function, and I will click on next. Perfect. So on the routes page, we have already added the routes, and now on the final step, that is stages. I will give it a name prod. This will be a part of our public URL. Click on next, and then I will click on create. Great. Once the API is created, you will be on its dashboard. Look for the invoke URL, and it will look something like this: HTTPS and then the endpoint. Copy this invoke URL. Perfect. So for this test, we need a tool that can send a post request. I will use a simple cloud shell that is provided by AWS itself. You can use any terminal, or you can use a Postman as well, a tool like Postman. So I will click on cloud shell provided by AWS for this demo. I will click open in a new browser tab for better understanding. Perfect. So I will click on plus so that a new environment is created. AP South 1 for my region. It is preparing my terminal. My terminal is now ready. Perfect. So I have this command ready for posting. So first let's create an item. I will send a post request to our URL with a simple sample data. I will just copy this command and I will paste it in the Cloud Shell terminal. Okay, so it has everything that is required. I will just replace this invoke URL with my actual invoke URL, that is this, and I will paste it here. Paste. Perfect. So you can see the message that is item created successfully. Great. So the item is now created successfully. This proves that your request hit the API gateway. It sent the trigger, it triggered your Lambda function, and your function successfully wrote through the DynamoDB. So the entry is created in the DynamoDB. Now let's try to retrieve that data. We will send a GET request. You can do this in your web browser also. So open a new tab and just paste this invoke URL. I will copy the invoke URL and I will open a new tab and paste it here. Perfect. You can see the entry that was created, it's now returned. Just for another case, what we will do is we will go to Cloud Shell again. We will do another post with a different data. That is data should be second item created successfully. Let's go back to this browser and let's hit the get request again. Perfect. So second item is also available now. Perfect. So you should see this JSON array with the item we have created. This proves that your entire stack is working perfectly. You have now built a complete data-driven serverless API. So there you have it. You have officially built your first complete data-driven serverless application on AWS. This is a massive accomplishment, and now you have a full project under your belt. But as you know, this channel isn't just about AWS. In our next video, we are going to dive into a completely new technology and explore an exciting new topic together. I'm so excited to hear from you what you want to learn. So please let me know in the comments below. If you liked this video, please give it a thumbs up and subscribe for more content. I'll see you in the next one. Thank you.